Hello, welcome to this video lecture, which is going to be about section 2.1 in the textbook, talking about first-order linear equations. So in this lecture, we're going to be going over sort of what they are, what they look like, how you can identify an equation as first-order linear, as well as spend some time talking about this interval existence business, which for separable equations was a little weird and had some weird properties where it might just stop randomly, but for linear equations, the idea is much simpler. So let's go ahead and jump on into that. So in this thing, we're talking about first-order linear equations, ODEs. Now, from what we talked about in one of the earlier videos, what this means is the highest derivative is only a first derivative, and the equation is linear in all of the y terms. So if you take those two things into account, the equation has a very, very specific form. Namely, it can only show up in the form of a function p of t times dy dt plus a q of t times y equals some other function r of t. That's it. There can't be anything else more complicated in terms of y and dy dt. The function of t can be anything, but in terms of the y's, it has to look like that because that's all that you could have in this setup. Um, if the function p of t is not 0, we can divide through by p of t and get a slightly different form. dy dt plus little p of t y equals g of t. That just came through by dividing by capital P. And this is between these two are the forms that we'll use to talk about first order linear ODEs. They can always be written in this form, and generally will also just show up in this form because there's nothing really more complicated you can do with them. Let's look at some examples. If I look at the function, the ODE, y dy dx equals 3x, what do I know about this? This is not first order linear. It is first order, there's only one derivative, but it's not linear because I have a product of y and dy dx. That makes it a nonlinear equation. On the other hand, I can look at this ODE, dy dt equals 4t squared sine of t minus 3ty, and that is first order linear. To match the other forms, all I have to do is move the 3ty over to the left-hand side of the equation, and then we're good to go. Like I said before, the function can be as complicated as we want in terms of t, but in terms of y, they have to be very, very simple. So that's pretty easy how you identify equations first order linear. Now, in terms of the existence stuff, whereas can the solution just stop existing because the curve goes vertical, we actually have a much, much easier condition here. We'll talk about this more specifically when we get into section 2.4 about existence uniqueness theorems. But as long as little p of t and g of t are continuous, the solution is totally fine. It exists, it doesn't go vertical, nothing goes wrong. The issue we had last time with the separable equations was that our condition for the solution existing depended on y, which was the value of the solution. So it really had no way at the outset to say, okay, it's going to stop here, it's going to have problems here, because it depended on the actual solution value. In this case, the existence stuff only depends on p of t and g of t, so if things go wrong, we know exactly when they're going to go wrong. You'll see that sort of going forward as well. All right, so that's sort of a brief look at what first order linear equations are, what they look like, because they're all very simple. I'm going to give you a couple problems to solve here, and these ones don't need to be solved as first order linear equations. The idea is that you can solve these guys as separable equations because they are separable. And the way in which you solve these guys is actually going to be vaguely important. It's going to show up again when we start talking about how we solve first order linear equations. So let me go ahead and write those examples up for you, and then we'll move on from there. So there's three examples of separable equations that are also first order linear that you can solve as separable equations, and then we'll see how this sort of technique shows up again later when we want to solve the general first order linear equation. So take a look at that, give me those answers, put those on the worksheet, turn that in tomorrow in class, and then we'll work on more of that stuff then. Thanks a lot for watching, and I will see you in the next video.